Hi, welcome to my channel. In the previous video, we discussed about the definition of decision tree, and some terminals of the decision tree like root node, and intermediate nodes, and leaf nodes, and also we discussed about the types of decision tree algorithms. Decision tree algorithms like ID3 algorithm and C4.5 algorithm, and also we discussed about the CART algorithm, and also we discussed about the how to train the decision tree algorithm, and also how to visualize the decision tree algorithm. That is training and visualization of decision tree with the help of some decision tree with the help of scikit-learn toolkit, scikit-learn. Okay, scikit-learn. And also we discussed about the how can you estimate or how can you predict the corresponding class level for a given dataset with the help of decision tree. In this video, I am going to explain about the estimating the class probability of a given data points. So that is our aim of the today's class. Now, for this we are using the standard data set like iris flower data set. It contains 4 features and one class label is there. One class label, that is X contains 4 features like sepal length, sepal width, petal length, and petal width. These are the 4 features are there, and also the corresponding class label is species. Okay, here the species contains setosa, iris setosa, iris virginica, and iris versicolor. There are 3 class labels are there, and also for our model we are using the petal length and petal width as 2 features. So out of 4 features we are using the petal length and petal width and corresponding class labels, species. Okay, so this is about our data set. Based on this data set, we are going to train our model. Okay, here the model is a decision tree classifier. Okay, decision tree classifier. So the max depth of the tree is 2. Max depth of the tree is 2 only. Okay, that means we are going to consider the decision tree up to level 2. So based on this information, we are going to construct the decision tree. So here the decision tree is nothing but here we are using the petal length and petal width and corresponding class labels like iris setosa, iris versicolor, and corresponding virginica. Okay, now here the 3 class labels are there. Now here we are going to estimate the class probability. So here we are going to connect the decision tree based on our model, our data set. Okay, so here a decision tree can be estimated the probability that an instance belonging to particular class. For example, we are giving the instance like petal length and petal width. We have to estimate the corresponding class label. We have to estimate the corresponding class label out of setosa, versicolor, and corresponding virginica. We have to identify the corresponding class label with the help of given input of petal length and petal width. So based on the information, our data may be belonging to any one of the class label. So we have to provide the class label for the given data set. That is our aim. Now, first of all, it travels to the tree to find the leaf node for this instance. Okay, for given instance like petal length and petal width, we have to traverse from the root node to leaf node for the given instance, and then it returns the ratio of training instance of the class K in this node. So now here, for example, here we are giving the input like petal length equal to less than or equal to 2.45, Okay, so for this information we have to identify the corresponding class label. Now if the petal length is equal to less than or equal to 2.45, that means that belonging to, we are checking the condition here. So this condition true, and then it goes to the left node of the tree. So either the left node of the tree contains Okay, one leaf node. It contains all the elements are belonging to one class. That class is called as a setosa. So like that, you are going to estimate the corresponding class label. Okay. Now, for example, suppose we have found a flower whose petal length is petal length equal to 5 centimeter long, and petal width is equal to 1.5 centimeter long. So for this given information, we have to identify the corresponding class label. So here, first of all, we have to check the condition. What first condition? The petal length is here the petal length equal to 5 centimeters. So here the condition false. So that means we are going to right side of this root node. Okay. Then once again we are checking the other feature condition. What is the feature condition? Petal width equal to 1.5 centimeters. So that means here that belongs to, here we are checking the condition here, that becomes true. So that means you are going to the right left of the corresponding tree. Okay. So here all the elements are belonging to, if the based on this information, all the elements are belonging to one class. That class is called as a versicolor. Okay. Here majority of the class belongs to versicolor. That's why we are giving the class label for the given petal length is equal to 5 centimeters and petal width equal to 1.5 centimeters. Now the corresponding leaf node is the depth of the left node. So this is the depth 0 and depth 1 and depth 2. At the depth 2, okay, the left node gives the corresponding leaf node. Okay. Now, so the decision tree should output the following probabilities. Okay. Here out of 54 elements, okay, 0 elements are belonging to setosa, and 49 elements are belonging to versicolor, and 5 elements are belonging to virginica. Okay, out of all these 4 elements, okay, all these 54 elements, the majority class is 49. So automatically for the given input to information, we are going to assign the class label as a versicolor. Okay, so now we'll see the probability of the corresponding class labels. Okay, here 0% of the iris setosa. That means 0 total number of elements by 0 of iris setosa by total number of elements of the entire data set, corresponding node of the data set. So that means 0 by 54, that is equal to 0%. And then 90.7% of the iris versicolor. That means out of all the 54 elements, 49 elements are belonging to versicolor, and remain by the total number of elements, that is equal to 54. For this, the percentage is equal to 90.7%. Okay, belonging to iris versicolor, and 9.3% of the belonging to iris virginica. That means here out of 54 elements, only 5 elements are belonging to other class, that is called as a virginica. So the percentage is 9.3%. So like that, we are going to predict the corresponding class label. And here, if you ask to predict the class label for the given data set, you should output the iris versicolor, that is class 1, because it has the highest probability. Here the probabilities are 0 and 90.7% and 9.3%. Okay, so here the 3 different percentages are there. So based on this 3%, highest percentage is 90.7%. So the index of this one is equal to 0 and 1, and corresponding 1 is 2. That means 0 nothing but your iris setosa, 1 is nothing but iris versicolor, and 2 becomes iris virginica. So here the class label 1 is nothing but your corresponding class label. Like that, we are going to predict the class label, okay, for the given data set. Now we are looking at the program part of how we are going to predict the corresponding class label. So here our model is tree hyphen classification. This is a model, that is a decision tree model, decision tree classifier. For that, we are providing the default criteria equal to Gini value, and the max depth equal to 2. So for this information, we are considered the decision tree, and also we trained our model with the help of tree underscore CLV. Okay, tree underscore CLV fit function. Further, we are providing the x and y. Here the x is nothing but a two features, that is a petal length and petal width, and y nothing but our class labels. So the class labels are here, iris setosa, iris versicolor and iris virginica. So now we are going to fit the class label for the given data set. Okay, given instance. So for example, the petal length equal to 5 centimeters and the petal width equal to 1.5 centimeters. For this information, we are going to put the class label. Okay, here the tree underscore classification dot to predict the probabilities for the two features. The two features are nothing but a petal length and petal width. The petal length equal to 5 centimeters and petal width equal to 1.5 centimeters. So based on this information, our model predict the corresponding probabilities. So the first here we are going to predict the three probabilities. So why you are getting the three probabilities? Our model contains three classes like setosa, versicolor and virginica. Okay, virginica. So okay, for that we are going to get the three class labels. Now the first class label is index equal to 0 and the second class index is 1 and third one is belonging to second. Okay, here the first class is belonging to, out of 54 elements, 0 elements are belonging to setosa, 45 elements are belonging to 49 elements are belonging to versicolor and 5 elements are belonging to virginica. So based on this information, we are going to predict the corresponding class labels. So here the probability is 0 and 0.90 and 0.09. So among these all these probabilities, we are going to predict the class label. Okay, so for that the majority is only 0.90. Okay, that becomes the index value equal to 1. So here tree underscore classification dot to predict the corresponding class label for the given input value. The given input value equal to 5 and 1.5. That is a petal length equal to 5 and petal width equal to 1.5 centimeters. Okay, now we are going to get the array of 1. Array of 1 is nothing but a versicolor. Okay, so that is our class label for the given input too. Like that we are going to print the class label. Okay. Now the estimated probabilities would be identical anywhere else in the bottom of the rectangle, right? Rectangle. Here, for example, here our point is, data point is 5 and the corresponding 5 and 1.5. Okay, so here the point is belonging to 5 and the petal length equal to 5 and corresponding petal width equal to 1.5. So that means at this point, the point is somewhere here. So that means the data point is located at the bottom right rectangle. Okay, like that we are going to find out the estimated corresponding probabilities. Suppose we are using some example like if the petal length equal to 6 centimeters, petal length equal to 6 centimeters and 1.5 petal width equal to 1.5 centimeters, petal width equal to 1.5 centimeters. Okay, at this situation the point also belongs to at this location. The point is also belonging to at this location. Okay, here the data point becomes bottom rectangle, right? Rectangle. Okay, so like that we are going to find out the corresponding probabilities. So like that we are going to estimate the probability of a given data point based on the decision tree classifier. So in the next video I am going to explain about the CART training algorithm. Thank you for watching our video. If you like the video, please subscribe my channel. Thank you.